from the last lecture. What is it that we're talking about now? Anybody can jump in.
We were on ICT, then we moved to investigation, and we were looking at guided discovery.
Okay. We were looking at those ideas when we were studying the impact, the pros and cons of using ICT as a tool for effective learning. Can we say in summary what we learned in terms of use of ICT in our classes or at our school? Anybody? I'm listening. I'm listening. Did you learn anything? Did you review your notes? Just tell me one thing.
That ICT cannot always be used in math classes. Because of the actual process, both the teacher and the students need a proper understanding of the equipment, whatever is being used, before it can be used properly in the math class or in any class, in fact.
Yes, that's one thing we learned. Can anybody help her? What else did we say? Did we talk about the use of calculators? Did we talk about some of the areas that must be explored before we introduce ICT? Did we say that ICT should be the subject before it becomes an object through which we learn?
We did. We also said there's uncertainty about the benefits of the use of ICT. There's always budget constraints in terms of getting the proper equipment, lack of knowledge of the available software and links between the computer tasks and the subject as well is a problem. Proper rooms to house the equipment is also a problem sometimes. Storage, we need good personnel to safeguard the equipment, also to assist with using the equipment. We need proper workstations and good networking in terms of Wi-Fi and things.
Yes, we need thank you. We need those things to be in place in order that once we begin to use the equipment, we will come to that point from the experience of having some professional development around the use of the material, around being able to make proper choices as to the software that we are going to use. We also need to have the good understanding of how and when we get to the lab, if we have to sign in, sign out, or if it's during our class time, or if the materials that we use, we must look at the objective at the very end to see if they were satisfied, if they were achieved. And so therefore, we have to make sure that all those things are in place. So to have the proper and effective use of ICT, we should have all those things in place. we need to know that sometimes the constraints that Jeffrey mentioned might not allow for the use of ICT. And unless we are going to use ICT in its proper manner, we will not achieve the results. Although we know that if we begin to use ICT in our classrooms, it could be a very effective tool, but we must have some know-how. Then what else did we move on to in the second half of the lecture? Nobody know?
We were looking at enrichment.
That is under ICT. But if we broach another subject.
Problem solving and mathematical investigation.
Yes, we did that. That's under ICT. What other subject did we consider for the second half?
Guided discovery.
Algebra.
Algebra, yes. We spoke about algebra. What did we say about algebra as a subject area? What did we say?
It's found in almost all other subject areas.
Yes, but we said algebra as one of the courses that the students begin at the 7th grade. What did we say was a very important fact about the understanding or the need to understand algebraic concepts? Did we say that algebra was the gatekeeper to higher mathematics?
Yes, we did.
So people need to be talking to me. What else did we say about algebra?
That if the students understand the basic algebra from the earlier forms, then when they get to the CXC level, they'll have a better understanding to handle more difficult questions concerning algebra. We identified some of the not prerequisites, but some of the things we wanted the students to come into grade 9 with. Grade 9, 10, and 11 with, like knowledge of directed numbers, knowledge of algebra, basic skills of plotting graphs, basic statistic skills, knowledge of area of plane figures, and so on. And we said from there we can work on what they know already. For example, when we were using the knowledge of area of plane figures, we said we can move on to compound figures if they already have knowledge of the area of plane figures by using manipulatives and so on.
Very good. But you know what concerns me right now is that Jeffrey Ann is the person who is answering most of the questions, and most of the people I'm looking at were at the lecture. What did we say in context about arithmetic and algebra? Did I ask that question so you could understand it? Nobody else wants to speak? We went into a long discourse about how we should view arithmetic versus algebra. We have to repeat what we did the last time for people to be able to participate. Well, let me ask you another question. What did we say about the type of skills that a primary school child would present with at the time that they enter high school? What number are they very comfortable
with? We talked about fractions, percentage, number sense.
Yes, but what set were we did? What is the set that they mainly deal with?
Positive numbers.
Positive numbers, or the other one that they're accustomed to is?
Negative numbers.
Primary school?
So primary school. They only learn positive numbers at the primary school.
Do they deal with zero?
And yes, zero.
So if we have positive numbers and zero, we are with the set of?
Whole numbers.
Whole numbers, yes. They oftentimes they report to high school with a good understanding of whole numbers and their operations. And so we have the situation where the students are very comfortable with that set of numbers. Good afternoon. Okay. So we have a situation where we say we could benefit, we could help the child to understand algebra by doing what? Since they come with those skills, they're comfortable with whole numbers and the operations resulting therefrom. What did we say we should do as we tried to introduce algebra, where we noted that algebra, beginning algebra sometimes is the beginning of a downturn in the person's liking for mathematics, or it's a place where they begin to show a decrease in proficiency. What do we say? How did we say we could use whole numbers? Remember that there is it is noted that there are many conceptual adjustments that are required for the beginning algebra student. How can we make them more comfortable and open the algebra door for them that they may enter and be comfortable, figuratively speaking? What did we say about that?
Is it that we could possibly use the whole numbers by saying something plus 5, for example, equals 7?
That's right.
And they have to figure out what the something is.
Did you hear that, class?
Yes, we did.
Yes, if we use parallel examples when we are introducing algebra, since whatever we're introducing would involve variables, we could line up something from whole numbers that would be a parallel situation. And in the very beginning, we should be working on ideas from whole number operations using and introducing variables, introducing and using variables so that they might see the parallel, and their sense of being lost would be reduced because they would be anchored with the whole number sentence or the whole number expressions. Did we say that, class? Did we say that? Class, did we say that?
I think we said it first.
No, nobody's answering me.
I think we did.
We said that we should use that because there is some transition from the thinking with whole numbers and thinking about ideas that are expressed with variables. Because they're comfortable with whole numbers, we should line up. Remember what we said. Remember, I use a fraction. When they add numbers of the same with the same when they add fractions with the same denominator, they keep the denominator and add the numerators. Remember, I used 1 over x plus 1 over x. Anybody remember that? Did anybody remember that?
Yes, I remember that.
Participate, please, because I want you to get this picture. You see what happens when we are in a course like this, as we study the nature of mathematics. What we want to do as dynamic teachers, as teachers who are going to escort the students into the world of algebra and exploiting what they come to us with in terms of their understanding of arithmetic. We are saying is they wouldn't be so lost. And if we escort them in with some degree of comfort, then probably as we go down the road, it would pay benefits because they're saying what we are doing, we are layering on the same ideas, but these ideas are now expressed with symbols or variables, which variable is a concept that they will have to understand, and we will have to explain it to them in terms of, if I have a number 5 plus 2 is equal to 7, right? I'm going to give you some examples in a little while. I know that if I leave one of those terms out of the equation, it should be very easy to find. So I would start at a very simple example for them to see that this thing has no mystery about it. There are cases where in a question that we call a closed question and we have open-ended. If we have, what did I say, 5 plus 2 is equal to 7, and we have x plus 2 is equal to 7, x is trapped. It can only be one value. But if I have a variable expression, an expression with a variable in it, like x plus 2, how many answers could I get from that? Right? Do I know, does it have a specific value? It could only have a specific value if what? If I have x plus 2. It can be equal to anything I want, right? So everybody could choose a different x, and that's the idea where the variability comes in. Are we understanding? Now let me say this, class. Anybody can ask me to repeat. Anybody can ask to give an example. If I don't have an example, somebody in the class might have it. And so therefore, I do not want you to remain silent because today we are trying to review what we did before, and I'm getting minimal participation. And that is not something that I desire. Did we say these things that I'm rehearsing?
Yes, we did.
Yes, we did.
Sometimes it's difficult to remember and even to just be writing a lot of notes. The 5-hour class. If we had some type of reference material, because you write notes all the time, but if you had something to read from, I mean, it would be easier if there was a reference or somewhere where you could read by yourself.
Yes, but you can always go over what the lecture. Don't you can go to it anytime? Can you go to the lecture anytime?
Usually.
That is
once it's
recorded. It's recording now. It's recording. But what I'm saying to you is this. If you miss a concept, and the other thing is there are note-taking skills that you have to practice. Take trigger words, right? Just, for instance, if you want to talk about the idea of using whole numbers to explain algebraic expressions or equations, just say, use parallel examples too. And parallel doesn't have to be the word parallel. You can make two strokes, like a big 11. So you have to learn to take some notes with trigger words or bullets. You write them down. You don't have to try to write down everything I say. You also could provide an example and ask if that is what I mean. So you can always jump in at any time. Okay? And you can revisit the lecture to hear of any part of it that you might, because I want you to get a developing structure as to what we are doing. Because we know that we have a lot of complaints about preparedness of students who come in at the 7th grade level. We blame everything, including the dog, why they do not have the skills that they're supposed to have. But it has been researched and found that most of the time when people do not understand algebra, nothing is wrong with their cognitive processes. Sometimes that is the case, but in the overwhelming number of cases, the student has the cognitive capability to understand, but it must be in a context. If I am coming to something totally new and every day I don't have the understanding of the core of the core variables, the core ideas, then I'm using them over and over and over and I'm still in a bewildered state. So we're saying line up the whole number sentences with the algebraic sentence. They understand what to do and they will make the transition. You form a bridge. And you know, the last time we were talking about the transitive property. Sometimes if I'm talking about an equation, you can write it down. So you have an example of what it is that we are lining up. I implore you to stop me, ask me questions, provide an example to test your understanding of what we are doing. Do we see that? Hello?
We do.
Okay. So we also said that algebraic ideas can be introduced in primary school with great success. Because every single day, maybe many times a day, even a first grader or a second grader is dealing with the idea of something that is unknown. And that is the main characteristics of finding the value of the variable in algebra. In the primary school setting, we can use symbolic or semi-abstract representations of variables. When we get to high school, we begin to be more sophisticated and more abstract. And people, students who were pretty enthusiastic and, you know, just being happy about doing math in the primary school, sees it as something that is beyond their capability, when in fact, that's not the case. So we have to introduce it in such a manner that they begin to grab hold of what it is we're saying and feel comfortable with it, because they're comfortable with variables. They're comfortable with variables. Now let us look at one example to show you that kids are comfortable with variables. It's just not called a variable when they're standing in the lunch line. But look, suppose a child comes up to standing in line with friends. And when she checks out her money, she doesn't have enough to buy what she wants. She's short by $10. That day is $10. But another child might be short by $5. Another child might be short $50. Do you see the short is the X? Do you see that short is X? So they know about short, right? So if one person is short by 10, one person is short by $5, the other is short by $50, the short there represent the different things, the different amounts. And so the shortness, if that's a word, assume different values. So it cannot, if it's not a mystery in the lunch line, we should make it a mystery in the classroom. Do we see that, class?
Yes.
We do.
A question there. Is it therefore better to introduce algebra, especially at the high school level, or reintroduce the part of it already? Using maybe worded situational things rather than.
We always encourage that.
Okay.
We always encourage that, because if a child is short, and we're going to say short plus that equals that, right? You're short 50, I'm short 5, somebody else is short 10. That is the variable. Everybody is not short by the same amount. If they want to buy something, whatever the amount is, that's already foregone conclusion. The total is what they're trying to reach, but they're short. And 3 different shorts is the idea of a variable. Because children do it. We shouldn't make it unreachable, inaccessible, mysterious, beyond anybody's ability to do algebra. Because, if you get the main ideas, the core ideas, you have greater success higher up the road. The other thing that must be learned is not only the context, but what must be learned must be the notation and the symbols. That has to be known, because we are dealing with new tools. And when we say short, we are talking about X, Y, Z, or any letter in the alphabet. We generally don't want to use S. We don't want to use O, because they look like 5 and 0. So some of those that don't serve us well, we shy away from them. But the thing is, we overuse X and Y. So if we stick to that, because that's mostly what we are going to see in the textbooks. So here we have a situation where they have a conceptual adjustment to make, and that should be easy. Then, as we present our lessons, we are building vocabulary and definition with symbols and words, so that they have facility in communicating when they are in a group setting, or when they're dialoguing with somebody else. They are able to use those with a great degree of comfort. So I am a little bit disappointed that you are not able to tell me 1 or 2 things about what we did the last time. So now I'm giving you, I'm being explicit. I think it was implied. You can jump in at any time for clarification or for an example, and we'll work together as best we can in order that you do not go away. Because there are some things that we must leave the class knowing. Because we are going to be the professionals. We are going to be the experts from the point of view of the students. And we want a class of 7th graders to be well prepared for the grades above. And when Jennifer Ann gets her students, they should not be struggling with the ideas of the core of this algebra. They should have transitioned in their minds. As I tell you, my little girl, she says, I just give it a name that I know and love or know and understand, and she gets there. Okay? Remember, we talk about if you have 5 bananas and get 2 more, these would be like terms. They know they have only bananas, so it can be combined, right? If they have 5 bananas and they have 2 oranges, you don't have 7 of the same things. And we have to say, now you have the start of a fruit basket. If you say, what I have in my basket, I can't say 7 bananas, or I cannot say 7 apples. I have to say I have 5 apples and 2 bananas. So therefore, if you can get it down to that level, they will understand that 5A plus 2B, the answer is 5A plus 2B. But if we have 5A plus 2A, we can come away with 7A. Do we understand that?
Yes, yes.
We do.
Yes.
Caroline, do you understand that?
Yes, I do.
All right, and Zana? Zana, do you understand that? Zana is not answering. Okay. Now, as we said, that if we are saying Jefferan, we are being specific. If we are saying students, we are being general. People know that. If a child is in a class and the principal sends a message or speak over the microphone and say, send me a child, I have a request here that I want you to see right away. Any child would want to go, right? But suppose the principal sends for Joseph Barker. He might not feel so happy if the principal sends for him. The first thing he might think, am I in trouble? Do you see the general and the specific? So arithmetic is the general, is the specific, and algebra is the general. Do we understand that? Hello?
Yes, we do. Yes, we do.
All right. So we said that the first thing when we are introducing algebra, we want to make sure that it is a feeling of, I understand this. You're just telling me student instead of James Brown. They're just telling me 5 is James Brown, right? And X is student. Do we see that? And we have different reactions to them. If the principal or the vice principal sends for, who is generally in charge of discipline, sends for a particular student, everybody look around and say, you are dead meat right now, because they know it might be something like, to discuss an infraction or something else. So we must not be bankrupt with ideas as we introduce algebra to our students, especially in the 7th grade, because that is going to be my foundation. That is going to be something in which I stand in order to get ahead. And if we are frustrated at that level, it continues. It follows that child or those children all the way up the ladder. And they dread going to math classes. They do not click their heels or clap their hands. They don't like the subject. And it's our duty not to be a turn off, but to be a turn on to the area, because it's not beyond their understanding. So we have said that probably you could meet with your elementary school teacher and tell her what is it you'd want. We had that. We did that where we met and we say, what do you want to see? What equipment, what ammunition should I be sending these children to you that they have safely in their bags? They can take it from their tool bag and do something with it. Okay? So here we have that. Now, the next thing we discussed was the core idea. The children who are very young can be given simple examples. But core ideas, we have to talk about transformational, global, generational. We have to talk about all these things in general terms that they're able to talk about in specific terms. So here comes the word, variable and unknowns. These things, they have to be introduced, and it's not difficult. It's not difficult. We have some things transformational. We have to take things somewhere from where else it is, right? Children understand that? Anybody understands that? Because sometimes, what are they standing at the bus stop? They are moving from one place to the next. Why the mother make her father, why we always say mother, but a father would make an arrangement with a taxi driver to pick my child up at such and such a time and take them to such and such a place. And sometimes this, I know of this case, is not good. It's not a nice thing to say, but it happened. This taxi driver had to pick up a little girl from one point and take her to school. And she had a pattern. The minute she entered the car, she fell asleep. The minute she entered the car, she fell asleep. So it became something that caused the taxi driver to have second thoughts. And so what he did was to say to the mother, does she get to bed on time? Because the minute she drops in the taxi, she sleeps. Turns out that she was being molested by her father or stepfather or whoever the man was in the house, and she was pregnant. And that's a true story in St. Elizabeth. The thing is that the situations that we see, we can tell, we can give some kind of ideas. And as I said before, this man saw something, it became a pattern. So what we have to do is to look at, that was not a good idea of a pattern, but it became a pattern. We have to introduce them to see, because what happened, variables put all the same ideas under the same umbrella. Under the same umbrella. Right? So now we have to look at the objects of algebra, variables and unknowns, sometimes they are called. So anybody or everybody should give me the definition of a variable. I'm going to start calling on people because I want to know that you're not asleep. Hello? What's a variable?
When I can change, it changes. It's not a constant, it changes with respect to a given situation.
Please say that again.
But it's something that changes. It doesn't stay the same. You cannot give it a definite value or something of that nature.
Unless it's couched in a closed-ended situation, right? So if I say x plus 5, it has how many? It has how many answers?
Several. You don't know because you don't have it equal to anything.
Yes, and if it's varying, everybody could choose a different value
and
place.
Value, right?
Okay. So now, same thing we call variable is the same thing we call unknowns. Do you know that if let us look at a birthday thing, right? My husband knows that I'm not a jewelry person, not the fancy jewelry like, you know, the diamonds and the gold and so on. I wear what you call fantasy jewelry. He buys me all of this and sometimes they get lost. I don't know where they are because I am not very careful. But suppose I say to him, I want something for my birthday. I like a watch for my birthday, right? What he does, he goes out and he buys a watch because he agreed that that is what he would give. That's not a variable. But if somebody gives you a birthday present, it's a variable until you open it. Isn't that true? Because you might not know what is in it. It could be anything, right? So for a child, it could be something as uninteresting as school supplies, as school is being opened now. It could be uninteresting to them as, because sometimes they don't like books and pencils. They would prefer what? They prefer an upgraded telephone. They would.
PlayStations.
Pardon me?
PlayStations, games, and stuff like that.
Yes,
the high-tech
games, yes. But the thing is that they don't know. So when you have a nicely wrapped packet with your name on it, it is still a variable because you don't know. But people my age and stage, I can say, I don't want any more jewelry. But I might come up and I might say, is watch a part of jewelry? I don't know. But I must say, I don't even own a watch today. And my husband got me a very expensive watch and I have no idea where it is. But anyway, if I say to him, he wants, like I don't give him anything, but when we're traveling, I pay his way. Like, you know, because he has everything. You know, another tie, another shirt. I mean, that's so uninteresting. And sometimes I take him out to dinner or something. But the thing is, when I'm taking him out to dinner, it doesn't matter because he wants to land up at a Chinese restaurant anyway. So there's no mystery there. And he has his favorite, which he will point out to you that that's where he wants to go. That's when the variable has a specific value. Do we see that? Because variables can have any names. All right? So now, we're looking at equivalence. How do we read an equal sign? The two short parallel lines between terms. What do you say? What does it show? What does it show when that sign is employed, that symbol is employed in an equation? What is it saying to us?
It's balancing. It shows that the left side is balanced to the right. They're supposed to be somewhat the same
value. Yes. Okay. It has the same value, but it might be equivalent expressions on either side. So we have to understand that, right? When we solve a simple equation and we have the variable on one side and the numerical value for the variable on the other side, that is equality. But if we have x plus 2 is equal to 5, that is equivalence because they're not exactly the same. See? So we can have that situation. Now, if I have, write this down, everybody. But I understand I can write on the board. That's what I understand.
Yes, because we can see.
All right. So, if I have 2 times a box, not a box, a square. That's not a box. Why is it not a box? Eh?
It's 2-dimensional.
A box is a 3-dimensional figure, something like that.
So, I want 2 times a makeshift square plus 15 is equal to 31.
It's equal to what?
31. Can you see it?
I can't see the 31.
Yes, I can.
Can you see
But to just shift from another side, we're not seeing the end of it.
31.
You'd have to, yes, you have to stay on that. Start from
From
there
there,
and go to
go
the
across
15.
to the 15.
No further than the 15.
I don't have any eraser.
Let me see if we can get them to see the 30.
Can you see the 31 now?
Yep.
I can see it.
Yeah, we can see that.
Yes, we can see it.
All right, now, suppose I have 2 times plus 15 minus 9 is equal to 31 minus 9. And this can be read for new students from primary grades is the same as. Now, this one right here is what we could term as equivalence, yes? Can that be, that can be termed as
Yes,
equivalence,
equivalent.
right? Because the expressions are different on either side, but what is maintained by subtracting 9 from each side? What is maintained?
Everything else is maintained.
The balance is maintained. The balance is maintained, right? Now, this is an equivalent relationship right here, okay? Because I have this, and we know that they even have a manipulative where they have a balance and they hang things on different sides and see when it gets out of balance and when it is in balance. Now, write this down. Write this down. 4m plus 10 equal 70.
Seven zero.
70. The question that is equation solving, right? Because we have the equal sign, we have the question to answer. What value of what in the sentence? What number of? What's the value of m that will make this sentence true? Right? That's what we're asking, really. Okay? All right. So here we have a situation where we have equivalent tasks because the equation provides the balance, but we have a situation where when we have 3 plus 4 is equal to 7, right? We just ask the question, what's the meaning of the equal sign in between? Or the symbol in between? We don't have to say the equal sign because then we are giving it away, right? But if we have the second one, where this one, right? This one is still an equivalence relation. And we are saying that is the number here, right? It should be the same in both equations. It should be? Yes, because all we're doing is subtracting 9 from both sides. So all we have a question to ask because we have written another equivalent relationship. And then we have the last equation that I gave you, 4m plus 10 is equal to 70, 70. All right, now, when we talk about equal sign, people just accept it, use it, and move on. Because we do not stop to discuss in any detail what equals mean equals. You cannot use the word to explain itself. That's not the definition. So sometimes I will say, what's on the left-hand side is the same as what is, or has the same value as what is on the right-hand side. Okay? So the relational view of the equal sign, if they understand it is a relational view, research has shown that they go on to do better in mathematics because they begin to understand. You don't have to have 3 apples over here and 3 apples over here, exact color, size, and shape to be equivalent. Because we have a variable in there, we have some choices, right? Then variables help us to do what? Remember I said that earlier. A variable is a what? Hello? Anybody?
That is the it helps us given a situation.
Pardon me? Will you please say that again, Zana?
I think we said that, if I remember correctly. That is basically the unknown. But you said that it is based on its own unknown given the situation. For example, like you said earlier, if you know your husband is going to give you a watch for your birthday, this is not going to be a variable because you know what he's going to give you.
Yeah. But if he wrapped something up nicely and we didn't discuss it, then I could open it and find anything. So the watch is specific, that's a 5, and the variable is the generalization. It can be anything. So variables generalizes, because remember we say that the definition of algebra is that algebra is the subject area that generalizes arithmetic. But we're not going to go in there with that big statement at first, right? So we're saying anything to which 2 is added is equal to 7, right? We can get the value of the variable. A variable denotes a quantity, so we get a number for it. We get a number for it. When the variable denotes a quantity, that's it. We have a value for that thing. Yes? 13-year-olds are generally the time when the student reaches the 7th grade, yes? First year of high school. Is that true? Some 12, some 13? Depending on the month and that kind of a thing. So they their interpretation of symbols is going to be important. We know that. Some of them don't look at it as a generalization, that it can be anything. So if you introduce it in that manner, then they begin to get the correct idea initially. And they say first impressions are lasting. Okay? So 6th, 7th, 8th grade students' interpretation of the use of variable, their results vary depending on how they were introduced. Because they don't even stop to think, they just panic. They just panic when it comes to algebra. They don't seem to think that I have any clue. This is the first I'm seeing this. Why the Lord made algebra, I do not know. That is their attitude.
I don't know what this is.
And you know what? And they said, what am I going to use X in here? When you are going to? That's no when, you use it every day. So you have a good answer and give them some examples where they use variables every day. The time they take to get to school is a variable because it's not exactly 10 minutes. If it's generally a 10-minute drive, probably something happened had a puncture on the car, the person showed up late. You know, it doesn't make, you cannot just give if it's 5 minutes trip, you can't just give the exact 5 minutes because you don't know what's going to happen. They use variables every day. When are you going to use variables? You're using it right now. So, you know, that's it. Now, let us look at the equation. Well, not equation. I'm looking at two concepts using variables and their expressions. Please write this expression down. 3n. 3n. And that's interpreted as what? How else can I say that?
Times n.
You can say 3 times n, you can say 3 multiplied by n, or n multiplied by 3. What we're going to say. All right? So you have 3n, that's one expression. I'm going to give you a second expression. N plus 6. Carlene, this is your question. Can you tell which is larger? Can you tell which is larger?
3 times n or n plus 6?
Yes, you're looking at those two expressions. And when you're looking at them, I'm asking you, can you tell which has a larger value?
No, I cannot tell because I'm not too sure what n represents.
Can anybody be sure? Can anybody be sure?
No, because n is a variable, so it depends on what n is.
That's correct. That's correct. Now, if my students can appreciate that in the 7th grade, we are set for success in this particular concept. Do you see why? Because if I have 3n to be equal to n plus 6, I would have to solve that equation. Do you see that? And if I solve the equation, what do I get? It would be, if I make that into an equation, right, I can solve it. But since I do not know, it's not an equation. You do not solve expressions, teachers. We do not solve expressions. We solve equations. Yes? Hello?
Correct.
We solve equations. And we can evaluate expressions. But if I'm evaluating an expression, what must I have to evaluate an expression? Since I cannot tell you what is 3n, how can I tell you what is 3n?
If you equate it to something, you must have an equal sign.
No, it might not. It might not. It could stay an expression.
Oh, sorry, no, you must have a value for m.
Exactly, exactly. Because what happens if I give an expression, this is a very simple case, but most of the time, what happens in the simple case is the whole story, okay? If I have an expression with n in it, and I want to find it, I cannot solve it because it's not an equation. I must be given a replacement value for the variable in order to give a numerical answer to the value of the expression. Okay? Now, what is one word for putting something in place of something else?
Substitution.
Substitution. Do we see that? Is there any child in school walking, running, riding a bike, being on a bus, eating dinner, don't know what the word substitution means? No, child. So the word substitution does not confuse children, right? So if I have 3N and I thoroughly give an example of what substitution is all about, my children are supposed to be able to get 3N, the same value, because I have given a replacement, a substituted value for the variable. Okay? So what is my job? The nature of mathematics say, if you tell me something and I understand it, I can execute it every time, because substitution doesn't change its meaning. What does it say to me or to anybody?
The teacher has to help the students gain conceptual understanding
Of the word substitution, but I don't think it's a big job. I do not think it's a big job. When I have a person in front of me trying to teach the class or just watching over the class, that person is called a substitute teacher. So really, a substitute is something in place of what is generally the case. So if I am your algebra teacher, and one day for some reason, some good reason I'm not there, and they send somebody in, sometimes the person doesn't know the algebra, but if I left an emergency plan, the person can, watch over them and see that they, work on what is suggested, collect the papers. That person is a substitute because my teacher is no longer there for today. So this person is in place of. Okay? So I have a substitute. Now I have a substitute, I'm able to function in the same way as I would if my teacher was there. Because if I say put 5 in place of N for 3N, everybody in the room needs to get the number, what? 5 in place of N. And now, yes, I gave you 3N.
15.
You're supposed to get 15. Nobody is supposed to get the wrong answer. What it is, I should have to explain to a student when they see the symbol 3N, they're supposed to interpret the operation as
multiplication.
As multiplication. So that has to be cleared up first. Do we see that? Hello?
Yes.
All right?
Yes, we.
So I need to give them all the tools and then ask them to work independently. Or probably what I can do is have them work in groups at first and then work independently. Because sometimes when you're in a group, you get an answer, and if you're not careful, I always call them riders, but not drivers. There's some people in groups are the drivers and some people are the riders. What does that mean?
Riders, they just copy what the others do.
They copy what the others do. They're riders, they are not drivers.
And the drivers do all the work.
That's correct. Because the driver has the whole responsibility on their shoulders. When you're driving, you can talk, but you have to pay attention to the road. You have to pay attention to other cars. You have to know where you're going and make the correct turn and so on. And the riders could be sleeping. Isn't that true? The riders could be sleeping. When we have a group activity, we do not want any riders. We want drivers. Yes? Because nobody's asleep. Everybody's alert, engaged, and so they can come away from the experience with the right information. So the operations are important, and those things have to be covered before you write 3N on the board and ask them to evaluate it. You have to tell them if a number without a sign between it is linked to a variable, then multiplication is implied. And please, I'm asking you kindly, at the outset, do not take anything for granted. Now let us look at n plus 6, right? For n plus 6, we would have to say the same thing, make a substitution. But this time, because of the symbolic nature of mathematics, we are not going to multiply, we are going to add. Do not take that for granted. Do not take that for granted. Now, let us look at the notion of variable again. Most common meaning that students at all grade levels provide for n in the task was that it was a variable, okay, which they are correct. And the answer to whether 3n and n plus 6, to say whether which one is larger, you have to say you cannot tell. Do we get that squarely in our minds? Yes. Okay. Now, if we have to replace 3n and use the variable 5, 3n would be 15. And if we have to replace the n with the same 5, the other
11
will give me 11. So here we are introducing the inequality signs, right? So depending on what the variable turns out to be, we need to know the correct sign to put in between the two expressions. Another way you can say, you can introduce, depending on if they know their English as well, an expression is like a phrase. Green book, right? But if I say the green book is on the table, then that's a complete thought. That is a sentence. So an equation is like a sentence, and an expression is like a phrase. Okay? Now, students' knowledge of the concept of variable may take some time to stabilize. So what you are going to do is to pound the information about variable definition so that when you're in the 7th grade and you're laying that sound foundation, you begin to use the same vocabulary. It is recognizable. Anybody who drives a car knows that sometimes you're planning to go somewhere else, and as you drive out of your gate, you go to the place you set out to go to the place where you always go without even thinking, because it's an automatic. So we want them to appreciate what is a variable on automatic. They're supposed to be able to say when you can determine the variable or when you have to be given a value for the variable, and you have to make that very clear. All right, so now we are going to be looking at transition to algebraic thinking. We say that our students who are coming from the primary school are steeped. They have been using whole numbers throughout these first 6 years, the first 6 grades that they pass through. And now they have to make a transition to algebraic thinking. Way down the road, I'm going to tell them about generalization. I'm going to say we don't know what it is until we solve for it, right? Now, sometimes they have use of restricted arithmetical word problems that focus on change problems. Joe, example, Joe has some marbles. What's the variable indicator there? If I say Joe has some marbles, what word is the variable being indicated by right there?
The word some.
Some, yes. Anybody unclear about that? Joe has some marbles. What's indicating the variable there? The word.
The word some.
The word some, yes. He won 3 marbles. Right? What would be a question to ask a child in a primary grade?
How many marbles did he win?
I told you. I said he won 3.
No, I thought you wanted a question.
But no, I tell you that's part of the given. Right? Can I answer the question? He has some marbles and he won 3. Can I tell you how many marbles he has now? Can I tell you how many marbles he has now?
No.
So
But
what am I dealing with here? An equation or
an expression?
An expression, yes. Joe has some marbles. He won 3 more. Who can give me a nice expression for that?
M plus 3?
M plus 3. Thank you. Do you see that? Now, somebody gives me an idea, give me a sentence to make this into an equation. Joe has 3 marbles. He won 3 marbles. He has some marbles. Finish that off into an equation for me, please.
He now has a total of 10 marbles.
So say the whole thing, Jeffrey.
Joe has some marbles. He won 3 marbles. He now has a total of 10 marbles.
So what can I ask in this case, since we have an equation?
Find out the number of marbles he had at the beginning.
Or you can say, how many marbles, right?
Have at the beginning.
Right. Do we see that? So you see the difference in the questioning. Do you hear the difference in the questioning? It must be clear in my children's minds. Yes? Now,
yes.
Listen to this one. Write this down. It's a few words. There are 8 riders and only 3 horses. What kind of question I could ask there? There are 8 riders and 3 horses. Eight riders, 3 horses. I'm listening. Give me a question. You have to make up these questions for your children, to give them many examples. So if I have 8 riders and 3 horses, give me a question I could ask my student given that scenario. Yes, Dana?
I was thinking we could say that John, but I don't want to use John though. But he has 3, you said 8 riders, right?
And only 3 horses.
and only 3 horses.
Yes.
So just now let me think of that again.
Give me a question I could ask.
Did you ask how could I represent the number of riders there are?
But I gave you.
I don't know, how could I represent?
You have to represent it with 8. I said 8 riders. Yeah, so there's no mystery about the number of riders.
So just now.
Expression.
Give me a question I could, if I give that to my student, what is the unknown? Or it's not so unknown now because I gave you the scenario.
Because it's the riders. The riders are unknown, right?
No, I know
That is 8 riders, you said.
8 riders. That's not unknown.
What? 8 riders.
And 3 horses.
It's a combination that's unknown.
But it's the H, that's the amount of riders that's unknown. 8 riders, you said. H or 8?
It's 8.
Oh, all the time I was saying H riders.
No, 8, the numbers that come between 7 and 9. It's 8. 8 riders.
Yes, I understand it now.
Okay. For a little child, what it is they need to find? What's the equation? What's the expression or equation?
An expression, just a statement you want them to give you. Just an expression. Write a statement to represent it. That's what you want them to do because there's nothing there to solve.
There's something there to solve.
Okay.
Is it like how many?
But all you said was, Joanna, yes, 8 riders and 3 horses.
What
You
question?
cannot add the riders and the horses.
No,
So,
I could say
so
what?
all you're asking them to do is to write a statement to represent the information you give them.
And if they write that statement, what would they write?
They will probably write 8.
That's the question.
But would you have to use?
Go ahead.
Now that's the thing. Now, that's a ticklish question you give us there. 8 riders, but how do I would just put the number 8 and 3 horses and number 3, so the answer would be 11. But it's to me it's confusing from the child's perspective, as to what you expect them to do.
Riders, right? If I would riders and 3 horses, what is the natural question?
How many riders per horse or something like that? You would ask,
Riders do not have
Horses.
or something like that. Yeah.
Yes. How many riders do not have horses? Right? Because for all the riders to have a horse, we need how many more horses? So that everybody would, because they're riders and some of them have nothing to ride. Do we see that? Do you?
Yes, I said now. I get it. Yes, I said.
Okay. How many riders have no horses? Because for each rider to have a horse, I must have 8 horses, right? And if I ask you how many riders do not have horses, right? Or do not have a horse, then I would have to say we need 8. We only have 3, so we need how many more horses? 5. Do we see that? That's change problems. That's change problem. It's like having what? It's like buying something, right? You want to buy something for $80 and you only have 30. Do you see that we can make an everyday example out of it? But teachers, you cannot just go with what the book says in terms of that. You have to make it so that the students can identify. And the idea of saying 80 and 30 is the same as saying 8 minus 3 because it's only bumped up 10 times. Do we see that? Do we see that? So if I want to say 8 minus 3 gives me 5, 80 minus 30 would give me 80 minus 30 would give me 50. So it's the same idea. There's a missing add-in there, right? So we need to know what it is and we can find it out. The other one with the marbles is a change problem. He had something happened, and you could either get more or less. But it's a change problem, right? Now listen to this one. Colin has 7 blue shirts and some brown shirts. Where is the variable? Where are we going to put it? So what expression you have so far? Let me read it again. Colin has 7 blue shirts and some brown shirts. So what's the expression?
The variable would be the
seven blue shirts.
7 plus B.
so it'd have to be 7B. So 7 shirts would be 7 anyhow. But the variable will be sum of the brown because you give a number for brown shirts.
Well, give me you're free, darling. It's a variable.
7
Plus B.
David said 7 plus B.
I agree with Dave.
Everybody agrees with him?
Yes.
All right, Miss Curly, you tell me now. He has 11 shirts all together. So we can go from an expression to an equation. So will somebody tell me what the equation is right now?
7 plus B is equal to 11.
Very good. Do we see that?
Yes.
So we can, since we have the total number of shirts, because all together means the blue shirts and the brown shirts make 11, because he's somebody who wears uniform, right? Now, what is the question I can ask now that I have that equation?
How many brown shirts does he have?
All right. And somebody can tell me that, right? How many brown shirts he has? How many brown shirts he has?
He has
4.
So, you know, it's the answer for sure, but we want them to build. We want them to build. You notice how I ask the question? I give them a piece at a time. He has 7 blue shirts and some brown shirts. So right after and, which means what? How the symbol is, and is symbolically translated. Plus. Do we see that, class? So we went from an expression to make it a sentence. We had to have a equal sign involved. Okay? So here we have the missing added problem, and we have a change problem. Now, the use of notation as a means of recording computation rather than as a description of what is known about the problem. So the notation we're using is the symbols that we introduce in the dialogue to make it a numerical sentence. And by the way, variables represent numbers very often, or most all the time. So if you have n in a sentence, it's still a numerical sentence. Do we see that? Okay. Now, Again, you can introduce this in a primary school environment because you're talking with them. We're not just up there doing and moving things from one side of the equation to the next and say, do these problems as practice. And you have to go around and talk to everybody individually. Not happening, right? But you're using their arithmetic thinking, right? And so for that, anybody who wants can write the parallel sentence to it. We know that 7 plus 4 gives 11. So if I say 7 and some, it would some brown shirts, then I'm going to have 7 plus B. So the B must match the 4 in the arithmetic sentence. Yes? And when it is an equation, the variable is trapped. Do we understand that? It cannot assume a variety of values because you have an equation. The equation acts like a budget. You know, our budget for the month, after we have all the deductions and all the taxes and all the this and that is taken out for health and for savings and 401ks and its equivalents is what? Yeah? It's not zero. You have to have what is called disposable income. Right? So this kind of exercise facilitates transitions from arithmetic thinking, which is x, 7 plus 4 equals 11, to 7 plus b equals 11. Do we see the parallel, class? Zana, do you see it? Zana? Zana, not there. Sabrina, do you see the parallel?
Yes, I do.
All right, everybody sees it. Good, I hope. Huh?
What time is it break?
4 o'clock.
4 o'clock.
Anybody can be my timekeeper.
I'm just checking.
Anybody can be my timekeeper. Okay. Now, as I said before, remember we say that we can look at historical facts for mathematics. And then we will see its true nature because we see how it is developed from one thing to the next, to the next, to the next. We know that when we are looking at the nature of something, some things we know if we buy plants or fruit trees or something from the RADA, the agricultural department, 10 chances to 1 it's going to bear sooner than the regular ones. That's the nature of it, right? Or pretty soon it might be shorter. It can be the dwarf version. It can, different things. And that tells you the nature. So if we are studying history, because we know sometimes we do it for practical purposes. Sometimes we look at math from a historical point of view. And it's very, very interesting that they started with base 5 because they had 5 fingers. Right? Then they went on to base 6. We have base anything we want. Okay? So the thing is, they created circumstances that facilitated the business that they wanted to conduct because nobody is sure that 28 chickens is equal to a cow. Do we see that? So the bartering didn't work. The bartering did not work after a while. That works between maybe family members. But when people bring the spices and the other things, they cannot take back cows for their, they cannot take back cows for their money. So they needed to establish a medium of exchange that is acceptable, and money was the thing. And so we have money in different denominations. So we say this thing is worth $10. This thing is worth $5. If I give you $10 to buy something for $5, I can get back change of 5, or I can get 2 of those things. And it becomes the standard. It becomes the standard. So we have mathematics, and it can be looked at historically. And you can see and get justification and take away some of the mystery. Take away some of the mystery. This thing landed in our laps, but it did not come out of thin air. Most of mathematics was brought into being out of necessity for use. Okay? Now, the an unknown hidden quantity, it lies in money, because you know money has value. Money has value, and who knows that so well? Besides people in developing countries. Because when Jamaica first got their independence, which is tomorrow, everyone, we had $1 Jamaica dollar equal to $1 US dollar. That's how things started. It was more than one when it started. All right. I thank you. It was more than one. A Jamaica dollar had value of point what?
I don't know if it was
1
less than
1 point something US, right? And now I just came from the bank. The bank is selling $1 US for 117. And if you take it to them, they buy it from you for 115. You see what I'm saying? So money has value. Money itself has value. You don't have to be buying a physical object to talk about the value of money. Building materials, the same length of steel is 3 times as much since 2003. I know that for a fact. So the thing is that money has value. Because of the holidays, vegetables right up in price. It was on the Facebook that a cabbage in Jamaica was sold. It wasn't a big cabbage, it was sold for like $200 per pound. A small cabbage was $600 in Jamaica. So the thing is, and he had the supermarket, you know, the supermarket label where they say what it is and how much per kilo and the date and everything. He did not make it up, but he presented the supermarket label. Yes, I have to talk to you after class about some things that I can get from where you live. Maybe.
You might be able to get much drought as kind of
stuff. Yes, but you know, there's not a drought everywhere. There's not a drought everywhere. So the variable then as a hidden quantity. The variable then as a hidden quantity. And for Jamaica, what is the value for $1 American dollar in your country, St. Lucia?
2.67 cents.
To get how many St. Lucia dollars you have to use to secure $1 American dollar?
Yeah, for answer that, sorry.
One US is 2.67.
St. Lucia dollars.
$2.67 EC dollars. It's $2.67 EC cents. Sorry.
So the EC is stronger than the US?
I don't know.
The US, one US is $2.67 EC.
Okay.
The US is stronger.
Yes, US is stronger. Yes. Do you know, I think that in Zimbabwe, I'm not sure, but somebody can look it up. It's like $1 million for a US dollar. It is so cheap in Zimbabwe. So money has value. And so it has hidden quantities in it.
Cheap in Guyana as well.
Yes, it takes a lot of Guyanese dollars to make a US dollar. At some long time ago, I heard it was 250. But we are on our way there.
Hopefully not.
Hopefully not. Hopefully not.
Hopefully we stop where we are. And then go back the other way.
All right. When we have hidden values, we can use manipulatives for that as well. Hidden quantity, you could hold up a bag and they can't see, it's not transparent. They cannot see what is in the bag. You can hold up a wrapped gift. That's a manipulative to introduce the idea of a variable. We can talk to them about the cost of an American dollar. Most people in Jamaica have some interface with American dollars in Jamaica, because we have a program. I don't know if you have that in St. Lucia, but if a student works for a summer abroad doing minimum wage, they can pay their school fee for the whole year. Given that they didn't borrow anything to get to the United States, they can pay their school fee for the year. So the thing...
Repeat that. What is it if they work?
There's a program at UWI right now where there are companies that students are processed to work, like at amusement parks or motels or any minimum wage job. And if they work for the whole summer, and that is really, say Hotel 6, say to one person in Jamaica, you can provide me with 250 students, you know, that kind of a thing. They can go there and work, come back, pay their expenses, and if not all, most of their school fee for the year, because of the value of the American dollar compared with the value of the Jamaica dollar.
Yeah, I understand.
So the thing is, I know a couple of people who have been, and I know some people who are there right now who are working, so that when they come back, they will have less anxiety associated with paying their school fees. You can say, I am going to buy a telephone, a cell phone. How much do you think I have in this bag? They know that they're varying cost. That could be a variable. You put it in a bag, you put it in a box, you wrap it, nothing can be seen. So you're representing the unknown with a manipulative. You're representing the unknown with a manipulative. There's nothing wrong with using a manipulative because it makes it concrete, and then you can move on to more abstract representations of the idea or the concept that you're trying to portray or trying to teach. The thing is, the teaching sequence, though, is important. You are going to represent math first with symbols that with which they can identify. A bag, a box, anything. The most common bag in Jamaica is a scandal bag. Hold it up with something in there. They can't tell me how many things are in there. Variable. Could it be 5? Yes, miss. Could it be 11? Could it be? They're getting the idea. But since we do not want to draw pictures, we give it a name. And anything can be used to represent a variable. So what happens, we're going to use X. We don't know the value, okay? So you look at those things. Now, the idea here, you will see that they use manipulatives when numbers were first introduced. And they were using symbols to represent certain amounts. And they weren't counting, they weren't multiplying, they were just saying, this is 10. Anywhere I see it is worth 10 of what you have, because we have decided that 10 of yours is worth this 10 right here. So that's what happened, right? Sequencing, you can talk about that because it's going to be a timeline. That is the path that this whole number system has come into play. Okay? Operations of adding equal terms. You have sides of equation, so you now have to remove negative quantities. Sometimes you multiply, but these things are well entrenched and you have to learn them. Generalizations and problem solving approach to transition. And we have given many, many examples. It's now 4 o'clock. It's now 4 o'clock, everybody. So we have lunch and report back at 4:30. Okay?
Okay.
Okay.
And thank you. And this one and this one. Someone gave me this and it's so nice. Oh, isn't that cute? That won't tell you what happens, but it tell you how to do it. Okay, what is it? Do you know? Lord of mercy, I hope it's not chicken. Let's go eat fish. I hope it's nice.
No, it's not. The taste like this.
This is yes, our taste. Because you know, it varied really. One day they had the, you know, the you cook the what you call it? The carrots and all of that. Soaked in vinegar and it tasted really good. One day it was plain Jane.
So let's go to plain Jane.
Oh, then it's supposed to be this.
Wow.
I'm going to check what mine is.
Okay.
Going to the lunchroom.
Yes, we should. I should take it on.
This is Dr. A. Bigman from the Cube. I'm trying to reach Dr. David Finney.
Oh, we're so glad to see you. Are we, Joey?
Oh, my friend, how are you?
Oh, he wants to know when that thing is coming out.
Well, that's exactly what I'm here to talk to you about. It was a complication during surgery. I'm personally responsible.
No, Joey and I are so grateful you're taking care of him. We trust you.
Well, the result was damage to part of Joey's brain.
No, his brain is okay. He's still Joey. You know, he understands everything, don't you, Joey?
Most of your brain is fine. It's working perfectly. It's just a small part. It talks to your diaphragm, initiates breath. That part is damaged, so you will no longer be able to breathe on your own.
You will get better, right?
The damage is permanent. I haven't given up. I found another doctor who may be able to help.
No. He wants you to be his doctor.
Oh, no, listen to me, Joe. This man has a new surgery. He may be on the corrector condition. No, that's his idea. He's done all the research. He is the best man for the job. He would need to implant a pacemaker into your diaphragm to make up for what your brain is no longer able to do. I'm not sure if this is going to work, but I think it's worth a shot if you will.
Hello, good afternoon. Well, I guess it is the last quarter of the day, so I don't expect it to get. Yeah. Well, from 29th of August, you're referring to? Do you have anything for the 29th of August? What? No. Okay. Mhm. Okay, all right. Yeah. Okay, all right. No problem. Yeah. Mhm. Oh, Sunday. Okay. Mm-hmm. Okay. All right, no problem. Okay, right. So in the time of intermission or whatever. Oh, okay. All right, no problem. Yeah. So how did that? So it's like more guys sign up for Bruzo and okay. Okay. Yeah, I think the guys think that they're getting the more exposure up north, so that's why they were doing. Yeah, yeah, yeah. Mhm. No, what I'm saying, like, maybe they didn't want to take part in the preliminaries down south, so they want to go and do it up north. Okay. No, since I
Zana,
you said that,
Zana, your mic.
so I thought they would do.
Sorry about that.
Everybody back? Good, thank you. This is our second half, and we are going to be looking at the generalization, the transitions. We have been looking at them. Now we're going to be looking at generalization and word problem, the problem-solving approach to transition. Because remember that 7th graders are really in transition. They're looking at variables and more abstract kind of concepts than they were accustomed to while they were in primary school. This man, Bednarz, B-E-D-N-A-R-Z, you say, I say Z. B-E-D-N-A-R-Z in 2001. Used a problem-solving context involving word problem to stimulate emergence and development of algebraic procedures in 13 to 18-year-old students. So what they're doing is, what he was doing is using the problem-solving approach to teach algebra. Mainly, he focused on that as he was teaching sequences, and those students that he had, they were labeled as students with learning difficulties, but they were able to succeed. That's why we started with what the teacher has to do at the beginning of this course in problem-solving situations, because it's not always that the students have learning difficulties. It's the way that we introduce and develop ideas in the math classes that discourages students and they get turned off. He had generalized number patterns that had to do with formula, unknown quantity in word problem solving. If the problem is couched in a scenario, that's what he used. Because the whole idea, the big word in algebra is generalization. The big word in algebra is generalization. And that seemed to pose a problem with many people when it's given or introduced in a formal setting like a classroom. They work with generalizations effectively without any hesitation in context outside of the classroom. The solving of algebraic problems is not very different. It's not very different. Yes, it's not very different from the basic things that they used to do, only that it spiraled upwards. And in addition to all of this, they had to learn to have new vocabulary or an enlarged vocabulary, and they had to learn some symbols that are unique to algebra. If we find a context that they can understand, we can do better for them, in that it reflects a situation that with which they can identify. Verbal description of things couched in a context with which they are familiar. They have, they can reflect on what they understand by those real life scenarios and make the transition to the more abstract or semi-abstract context. Now, one other good way of helping the students who are on the threshold of abstract mathematics using variables is to let them make a problem. They can pose a scenario, including questions. Now, what I want this class to do right now is to look at a generalization problem. Generalization presupposes that you're going to have a what? If it's generalized, we're going to have what? A variable. So I want you to take about 5 or 6 minutes to write your own problem. And we are going to look at them per person so that we can decide what is the variable and what is the resulting situation. I urge you to think about stuff that you do everyday decisions, because I want something in a real life context. It can be something that you do that involves a variable. You do it effortlessly, so you have to think a little bit deeper to identify, because the level of mathematics that the ordinary person does, you'll be surprised at how much math is hidden in it. I'm not talking about things like, the rules for forming an equation or something like that, but I'm talking probably about travel, probably anything that you want to do in your everyday life. So you have 5 to 6 minutes to make up a problem. We can discuss it to find out where the variable should be introduced and probably what the situation looks like. Sometimes it's age problems, what for John is twice as old as the youngest sibling or something of that nature, and what we do with it. And the last time we were talking briefly about the transitive property, but we didn't clarify what it looks like in structure. So we will talk about that as well. You can talk among yourselves, although you can talk on cell phone if you want, if you're not together. The author I gave you the other day, Bernard's, earlier, I gave you somebody who did some research and published a paper. Bednarz, Bednarz. He has a lot of examples. So it's now 4:43. So 6 minutes should take us to say 4:50. It's 47 minutes will take us to 4:50. We'll stop there and I will be quiet. So I'm turning off my mic. How are we doing? How are we doing, class?
It's okay.
It's now 4:51. Are we ready to share?
I'm ready.
Okay. Anybody else ready? Anybody else ready?
Nelson, one quick question. Do you want it with just us forming an expression or both can it have both the expression and the equation?
Okay, what did we say we are going to do? We're looking at a generalization problem, right?
Yes, so I'm asking, is the question only forming the expression or you want it forming the equation as well?
You can do, you have a choice. You can do whatever because both of them exist in the curriculum.
Okay, because I did both. Are you ready?
I think nobody else has answered me. Sabrina, are you coming? Sabrina?
I'm here. I'm not ready, but you could start. I'll be ready by the time some people present.
Okay. Zana, how about you?
Yeah, I'm ready when y'all are. I'm ready.
Okay. Diane?
Yes, I'm ready.
Okay. Miss James?
I just logged on. I've been having some internet problems, so I don't know what's going on.
Okay, all right. We'll cue you in. What about my people here? What about my people here at Mona?
Why should I speak?
Yes, you have something.
We must have language. We must have symbols because, you know, that's what we've been talking about. Language you learn, symbols you learn, context you contrive.
It's a different thing than this. It's not the same. It's not the same.
It is not easy to be originally creative unless you can think of something that you do, you know, that involves a verb. Okay? And we have to describe it using symbols. Okay? Now, people are hearing me. Zana, you want to go first? Hello? Zana, do you want to go first? I have to get some paper and have a pen. I have to get some paper.
No, I don't want to go first.
You don't want to go first? Let me just say this.
No, get over go first. Get over first.
In this environment, anything you do is okay because if it's not factually or constitutionally correct, we just correct it. Okay, so you want to go, Davi? What did you say was your problem? Do you want to write it on the board? You know, I need some paper. That's my question. You want to write it on the board? Or you just want to talk us through it?
I'm not sure. Let me just read what we have started with.
Okay. I didn't have an eraser. All right. We're listening. Speak up.
Okay. A jumbo cone costs twice as much or 2 times as much as a regular cone. Stacy buys 2 jumbo cones and 5 regular cones. And I think that's where, at that point here, before we go to the cost, I think we could put in the expression there.
Yeah.
You want the expression?
No, we are going to do it. The class is going to do it.
Okay, the class will put in the expression.
All right. So, did we hear the scenario? Everybody? Hello, class.
Can you repeat it? I didn't get it clearly.
A jumbo cone is twice
Dr. Nelson, your mic is on mute. Your mic is mute, so we're not hearing
you. Okay. Did you hear the constraints on the problem?
No, we didn't.
Okay. 1 jumbo cone is twice the cost of 2 regular cones.
One regular cone.
One jumbo cone is twice a regular cone. Okay? The person purchased 2 jumbo cones and 5 regular cones. So we're going to form an expression for that. Do we have it now? Do we have it now? Can we write an expression for 2 jumbo cones and 5 regular cones? What is our expression right now before anything else? We're going to say jumbo phones can be represented by the variable J, and regular codes can be represented by the variable R. Are we in agreement with that? Class?
Yes, we are.
So what statement do you have written? What not statement? What expression do you have written on your paper?
2J plus 5R.
Is that a consensus? Is that a consensus?
Yes, it is.
All right. Do you want to finish the problem now, sir?
What? Okay, the other part says the cost. She pays $450 for the 2 jumbo cones and the 5 regular cones.
Okay, you want some cheap cones?
Oh yeah, they're cheap.
Cheap phone?
You want the cheap.
The only thing I'd like you to be, did you hear what was the cost of all of those things? Class?
No, we didn't hear.
She said 2
jumbo cones and 5 regular cones cost $450.
Did you hear that?
Yes, got it.
I want to make a comment on that. Who else wants to make a comment on that?
Using 2 variables will give us quite a challenge. I think if we let the regular one be X and the jumbo, it's seen as twice the 2X, it makes it easier to work out.
Beautiful, beautiful, beautiful. Because J and R are 2 different variables.
Yeah, cannot have 2 unknowns.
2 different variables. How many equations do we have to have? 2.
2 equations, but
who observed that? Diane?
Yes.
Very good, very good. And if a child tells me that in class, I fly immediately, unaided, the way I'm happy. Because
but the first sentence says 1 jumbo cone is 2 regular cones. So I was assuming that automatically after you get the expression, you'd have had to substitute 2 regular cone as the price, the value of 1 jumbo cone. There was substitution.
Yeah, my sentiment exactly. That's what I was thinking.
That was the first statement, so you'd have to substitute.
Yes, but you know what? Because we are mature people and we know what we are doing, we do that. But you know, some children would look at it with eyes of mystery rather than saying it's automatic to make 1 variable for 1 equation. So Diane, you get the applause because that is something you want your students to say. That is something you want your students to see. You see? Now, I have another comment. Anybody has any other comment about this problem?
I didn't get the instructions. What were the students required to do?
2 jumbo cones and 5 regular cones equal $450.
But that's what I'm asking. What were they required to do? The question I want to know, what was the instruction?
The question hasn't come yet. We're just building.
Oh.
And somebody.
No, I think the amount of money used, I would not have used. I wouldn't use $450 because the practicality of it in terms of being, I don't know if ice creams or cones are so expensive in Jamaica, but I wouldn't use $450. I'll probably use $20 or $10. I wouldn't use so much.
But it's contextually correct here.
Jamaica, that's Jamaican.
How much it is for a cone?
Probably twice that.
That's where I have the problem. I think it's too cheap. And you need to stay realistic with your students, because every last one of them have been to Devon House.
Yeah, I think probably
if it's in Kingston.
Probably at school. This would apply at school, but certainly not at Devon House. Devon House is at minimum 6 times.
So what that takes on your part then is flexibility. So when if we're in Kingston, and the cone in Kingston minimum, I think is $200 or something, minimum. What I'm saying, well, the thing is, contextually, you stay true to your area or your environment, because it makes more sense then. You know, in places where people farm, right? And when we say people farm, we think they're farming for a living. If you're not farming for a living, you say your house garden or your, you know what I mean. But the thing is, stay true to the situation, and that is called teacher flexibility. That is called teacher flexibility. Okay? So we have 2J plus 5R plus 5R, and they say that it's $450. So I had a question, I had a thought about it being too cheap. It needs to be more expensive than that. Okay. All right, so now.
Who was it that had the concern that was too expensive?
Exactly, as Dana was saying, if we're going to use that example in St. Lucia, we cannot use that price because it's extremely expensive. A cone is probably about $2, $3 maybe. So that figure would be extremely high for St. Lucia.
Yeah. Well, the thing is, that is what I say, you have to have teacher flexibility. That's why this brings up, that's why we are flexible when we are, because it has to make real sense to the student for it to be identifiable with their situations. So we have different currency values, we have different currencies, so we would stay true to our context. All right? But for right now, let us say this is context free and we are going to work with the 450. But we have one equation and two unknowns. So what is important here? So one jumbo cone is how many regulars?
2.
All right. So if we know the conversion factor, then we
need to make the variables the same.
Exactly. All right. So if 1 is equal to 2, 2 must be equal to
4.
4. So we have, how many cones we have?
4R plus 5R.
4R plus 5R.
5R.
But do you see, what is it then that the child needs to appreciate before they can get to 4R plus 5R? They have to appreciate that an equation, one equation, can only be solved with one variable. I jump over the moon if somebody tells me that without prompting. No, I'm serious. Eh? Yes, I would, because that is the core of the situation. We talked about the value from the point of view of teachers, in that we are not going to make something unrealistic. You see what I'm saying? Like if we are drawing say a scalene triangle, we should remain true to the definition. And it must be obvious. It must be obvious. I must see it. You see? So if it looks too much like an isosceles triangle or an equilateral triangle, then I'm not being true to the context. But in St. Lucia and Dominica, you go with what is reasonable in your context, right? And so now, instead of 2J plus 5R equal 450, we are going to have 4R plus 5R. So what is embedded in that, first of all? What's the first thing they have to recognize? After we have the 4R plus the 5R, what concept?
Like terms.
Yes. We have like terms or similar terms or terms with the same, you know how I teach that? Same last name. They form a family. They form a, one entity. But if they have different last names, right? In general, we're saying families have the same name. If they have different last name, they can't form one entity. Some are going to get the last name by marriages, but everybody in that family reunion, we're going to say, have come from the same roots, so they have the same name. Now, I'm not going to ask you to solve that, because that is not the point. The point is that we are looking at the situations where we have the way of constructing, based on the scenario, how you construct these equations and what you have to know in order to bring it to the point where it can be solved. So now I'm listening to Diane, because she has one.
Maya opens a cell phone store. She makes $50 on every cell phone she sells. Her monthly expenses are $6,000. What is the minimum number of cell phones she needs to sell a month to make a profit?
$50.
She makes $50 on every cell phone she sells.
I don't understand when you say $50. She makes $50. Is that a profit?
Profit.
Yes. Profit on every cell phone she sells.
What did you say the monthly expenses are?
$6,000. What is the minimum number of cell phones she needs to sell a month to make a profit?
All right, any comments, people?
Well, my first comment is they would have to know something about profit to be able to derive that equation.
So they would have to have a profit equation. I don't know. Profit equation involves how many variables? Profit equation involves profit. It involves
cost, price. Depends on what you're looking at.
Yes. What's the question? How much? So you're talking about cost and light and rent and helpers pay and everything is $6,000 a month. Everything is
Yes, but what I gather here, the 6,000 will be the fixed amount. So that is fixed.
Mm-hmm.
So the number of cell phones will have to cover first have to, but then I don't know. The amount of money she makes first has to cover the expenses. It's a particular issue though.
She gave the extra
Me,
that she makes.
if you're going to answer that,
Uh,
I
the cost is already covered
the
somewhere
amount
else.
of money that she
She's
would break
accounted
even
for her
and
cost.
then any
She has
phone that she
$50 left over from each one that she sells.
$50 per cell.
So
Extra. What
your
she has
question is how many cell phones she has to sell to?
To make a profit, sell a month to make a profit.
All right, so what is the equation, class? What is the equation?
But Diane, to me that would be because if it's equal, if you use equal to say like 50x is equal to 6,000, that's still not going to be a profit. That's going to be break even. So it would be greater than or equal to 6,000. That would give you a profit.
I agree with Sterling. It would be an inequation, not
Ask you no. I mean, the thing about if you let X be the number of cell phones sold,
Mm-hmm.
then I mean, all you have to do is to sell more than, and you make the profit be zero, as the person was saying, right? So 0 is equal to 50x minus the 6,000. That's your equation.
Yes, that's what we
So
have
do
to
we
do.
have an equation or do we have an inequality?
yes, that's what it will be. Because what we're saying is the value you give to X will not be the solution to the question. It will be
Right.
X than
So
that answer.
what is our inequality? What is our inequality?
50x
It
is
doesn't
greater
have
than
to be an inequality.
It doesn't have to be?
I mean, it doesn't have to be. I mean, once you make it profit, it will make it equal to 0. And you work it down to 120 phones. All the answer is she has to sell at least 120 phones. You have to make that inequality.
That's
It's
why
not necessary.
She's actually breaking even. She's not making a profit. You ask the first how much.
Right.
But the question asked the minimum.
Was the minimum number of cell phones she needs to sell.
That's exactly what I was saying.
So once she makes the 120, that's the minimum amount. She, I mean, after that, she has to sell at least 120 phones.
But you asked to make a profit minimum. You said
it should be for her not to make a loss, not to make a profit.
No, all you have to say she has to sell more than 120.
I agree with you, Diane. My equation that I have though is an inequality because I want her, my equation is this: 50C is greater than 6,000. So C must be greater than 120. Do we see that? If she wanted to make a specific named profit, then we would have a different equation. But if she makes, if she sells 121 phones, she's going on with $50 for the month, right? So if you want to get in another symbol that they have to learn, I would place the inequality because least means that or more, right? She breaks even if she sells 120 cell phones. But if she's to make a profit, she has to sell more than 120. That's why, Diane, I would place, the interpretation and the reporting that you have done when you have constructed an equation is spot on. But to just read the answer, if you have a inequality sign, which would be a good thing because that is one of the symbols that we have to practice.
But again, to me, I believe that when we are teaching children, I think is the way we pose our questions that can either get children away from answering the question that we're asking. Because the question specifically said that she sells cell phones and she makes $50 profit. So you're already telling us that she is already making the profit. Now, the concept of you making a profit is cost price minus selling price, something of that nature. So the students in themselves, as much as possible, we don't want to confuse them. I don't know. I would have posed the question that she needs to sell, the cost price of the cell phone is X amount, and then, she's selling that something. So just so that we don't get the children confused as to what we really want them to get.
Yeah, but how would you use that? What you're proposing there would give us a nice, clean equation with the cost price, the selling price, and the profit. But I don't know if the children. That's what I'm saying. If somebody could tell me this, I'd jump over the moon.
I still think there's something wrong with the way we solve this.
Because you're getting profit from each phone, but then you're going to ask them to use this profit to offset their operating costs. That's exactly what we're doing.
No.
Expenses.
She breaks even if she sells 120 phones. She can meet her expenses. Light, rent, employees, transportation, all the other things that go into cost.
The initial statement says that she this amount or this profit from each phone.
So if I know the profit from each phone, I know the profit from as many phones as I want to.
How much profit does she make?
Oh, that was not the question.
And that's what I'm saying. It can be confusing because they are thinking.
No, depends on the question. Depends on the question. Because remember the other day when we were talking about the overcrowding, you could have more than one objective. Here, if she has to make a profit of what's a reasonable amount, 200,000, whatever, right? Dollars, right? Then you would have, that's a different question from the one she's asking, because she's saying, you have to see where the inequality comes in this question that she's asking. So if you ask that question, you have to give some more information.
Dr. Nelson?
Yes.
Question.
I was saying, the way we solve it, we have 50 times X is equal to the 6,000. We assuming that the 50 is revenue because what you're equating there is revenue and expenses, and that's the break even. Because if $50 is the profit, it means $50 profit multiplied by the number of phone is not equal to the expense. I mean, the information is inadequate to solve the problem.
You think so?
I don't think so.
I don't think so.
No, she's getting all her.
She's getting all her $50. Yes,
from selling phones.
From selling phones.
And when she's done selling phones, she makes.
The $50 she's getting is not that's not what she's that is the profit that she's making,
Pounds. I don't know.
That's not revenue, that is profit. The $50 is profit, it's not revenue to say it is she's making in addition.
I asked whether it was the profit or the price of the phone because it makes a difference in terms of how you state it.
That's not revenue, that is profit. The $50 is profit, it's not revenue to say it is making in addition to.
What is profit? What is profit? Profit
is an excess of your cost price.
Right.
So after she's taken care of cost price, she's got $50 per phone there.
After she's taken care
of her cost price.
Yes.
$50 per phone.
Well, what is embedded in this, right? If we have 50 times cell phones, right? She'd have to, it takes into consideration that she has already paid for the phone, whatever they are, and she's making $50. So how should that? It is assumed then that she has taken out what she spent. She has taken out what she has spent, but we are looking now because we don't want any of our cost price. We don't want $6,000 to be our it's a cost. Yes. So probably that will take some more.
6,000 is included But that's a total operating cost.
That's total operating cost. That's what I'm saying. It's embedded.
Yeah. So right now, you have to get down.
That's not what
Exactly.
Well, that's not what Diane said.
But that's all the reason.
Diane?
Yes.
Yes. David talking to you.
Can you repeat the question? The operating, what was the operating cost?
No,
how much expenses?
Expenses.
Yes.
His monthly expenses.
Was $6,000.
What was the question you wanted us to answer?
Do you want the monthly expenses into
So
the
I guess
cost of
the
the
monthly expenses would therefore include the cost of the phones.
All costs.
All costs.
Yes.
Right there?
Yes. Monthly expenses is $6,000.
So what is the question?
The question is, how many phones she has to sell to make a profit? Because profit is beyond the cost. What is it you have to make beyond the cost? Whatever the cost involved. So if the cost involved, maybe the number is unrealistic, why people don't. Yeah. Okay. All right.
Hello.
Yes, I'm listening.
Hello. Yes, what I was saying, if you still looking at kids per se, but if you're going to use this is what the question says. She makes a profit of $50 on a cell phone. I think that different terminologies, especially for children that we're looking at of the day. And then now you're telling me, and then thereafter you see that $6,000 in operating expenses. So you want to know at least how many cell phones must she sell to make a profit, to now make a profit. You understand? You understand the word in the question? She said that it makes $50 is made on its cell phone. So obviously the trend will not arrive at an equation for you. It will have to be an inequality.
Yes, that's what I said. All right, Jennifer Ann, could you give me yours?
My question? My question you want, or my opinion?
You are participating if you give me this.
Yes.
No, I'm participating. I'm asking if you want my question now or my opinion on the
your question now. We're trying to move on.
Okay. All right.
But you know, hello, Jeffrey. Feel
Yeah.
free to give me your opinion.
No, I gave it during when they were all speaking. I don't know. Okay. Glenda is M years younger than Sylvia.
Who?
Sylvia is Glenda. Glenda is M years younger than Sylvia. Sylvia is 13 years old.
Sylvia?
If this is 13 years old.
Who is 13 years old?
Sylvia. Sylvia is 13 years old. If the sum of their ages is 20 years, A, write an expression to describe how old Glenda is, and B, what is Glenda's age?
What is Glenda's age? That's the B part. What's the A part?
A part, write an expression to describe how old Glenda is.
Okay. So we're writing an expression. What is Glenda's age? And write the expression first. All right, everybody, write expressions now, please. Glenda is M years younger than Sylvia, who is 13 years old. Jeffrey?
Correct. Yes, correct.
Yeah. First thing you have to do is write an expression.
The sum of the age.
20 years.
Sum of ages. So equals 20. What is your equation? Well, everybody, give me the equation that is expression or equation.
Expression is first.
Expression is first.
First.
Expression for
both of them.
For Glenda's age is 13 minus m.
13 minus m. And then you said the sum of their ages.
The sum of the ages is 20 years. The sum of the ages is 20 years. You got that?
So everybody now, besides Jeffrey Ann, tell me what you have gotten for your equation.
13 minus m plus 13 is equal to 20.
Everybody concurs?
Yes.
13 plus 13 minus m equals 20. Okay, now let us look at this. What is our justification?
That
how would we help the students to build the, first of all, Glenda's age using an expression? How would we help our students to do that? What would you say first? Or second?
Since Glenda is younger, then they have to figure out that, well, help them realize that they would have to subtract their age because she'll be younger, so her age would be smaller than.
You help them to know that it has to subtract Glenda's age from Sylvia's age.
Yeah. Glenda's age would be smaller, yes. So the difference is, since Sylvia is 13 and Glenda is younger, she said Glenda is M years younger, so we'd have to subtract the difference of Glenda's age.
Is that the way you would go about it? Anybody else has a different approach? Does anyone else have a different approach? Nothing.
I would use siblings. I could use the students in the classroom.
Nothing is wrong with what you just said. I just want to know if you are that's the only way you would introduce it. What dialogue would you have with your class as they try to build the expression for Glenda's age?
I would use the students in the classroom. I would use the two students, and I would have one to represent Glenda and one to represent Sylvia. I mean, so that they could understand that who is older, younger, and use the letters for Glenda to see what and which one is 13 years younger, 13 years older, 15 years younger. We could just label them and then get them to see instead of get them to sit and then to the.
Yes. Hello? Can't hear anybody.
Hello, you didn't hear what I said?
No,
you heard me?
We lost you, but we got back. We got back to you. We lost
okay.
Internet, yes.
So what I said is that I would use two students in the classroom. I would give one the label for Glenda, which is the M years younger, and I would start off with Sylvia. So you know Sylvia is 13 years, but Glenda is M years younger. So I would do, so that just to make them see that this person is younger than Glenda. And then we'll use the equation, use the expression, we'll use the words, the mathematical language to write the expression, and then we'll go about solving the equation.
What would anybody else do? Anybody else want to say something? Go ahead.
I'm trying to formulate it.
You're too silent. You're too silent, mister. Please, please. I don't want any riders. I want drivers.
Instead of going straight for the variable m, I'd probably try to use the students and say, find out who is like 12 years old, 10 years old, and show who is younger and delineate the difference. Yes. That's all I've got.
Okay.
So this person is 12, this one is 10. This one would be 2 years younger than this one. So we know that we have to subtract.
Yes. I think that you're on the right track, because my comment is this: your comment is not wrong that you use the students, but I would rename them so that it becomes personal, because kids are narcissistic. They love to talk about themselves. They look at themselves in a mirror and it glows. So I would change their names. I would change the names in the problem to identify with the students in class. I would make most of the students in 7th grade would be in the same 12-ish, 13-ish, whatever, right? So I would say, if I want to find out your friend's age and you are older than she is, what would you have to do? So the older person, I now have your initial. And so I would let them say, I would have to subtract her age, the younger one, right, to find out what is the person's age, the difference in the ages, right? So I would do that. I would make it personal, because not everybody's perked up. Okay? So if sometimes I might have to assign a fictitious age, but probably in the 7th grade, one might be 12 and one might be 11. Yes? Because if they're one day before the 12th birthday, they're 11. So we could do that. And they would see it's only a difference of 1 year, because we expect them to be in the ballpark. Yes? So then, the next thing I would do is form, just with the initial now, not with the expression yet, your age plus your age is 20. But your age look a little different. So we make that substitution vocabulary. Do we see that? And then we would get the equation that everybody has already gotten. And what is the equation again? 13 plus. Yes, it's that. Okay. So then, let me ask you this. We have to represent 2 people in the problem because we're talking about them. So we have to nail that with the kids. Okay? So I would even I can have permanent plus and minus signs made out of cardboard in my classroom. And we could get somebody to hold up the plus and somebody to hold up but whatever is somebody to hold up the inequality sign in between the 2 people. So you have a name right now. You're just a signpost, the one in the middle. And let them practice that, okay? And they know themselves already. They know in time we're talking about that we need a signpost. You go pick up the signpost that you need and that kind of stuff. So now, if they suppose they just had 13 minus m equals 20, and they solve that problem. Solve 13 minus m equals 20. What do you get?
But is that 13 minus m is equal to 20?
Yes. So the answer would be, if they made a mistake, which is fine, because it's going to show me now if they have number sense.
They will have gotten -7, but somebody's age cannot be negative.
So you see, if they make a mistake, teach them a moment. When were you -7? You know, just to. So we didn't know you, we couldn't call you, we couldn't compare to somebody else. So our age cannot be negative. Do we see that? Do we see that? All right.
Yes, we do.
All right, very good. Somebody else want to share? Miss Promise. Sabina.
Yeah, mine is pretty simple. Sam and his baby brother Mark together weighs 125 pounds.
What did you say? Please say it again.
I said Sam and his baby brother Mark together weighs 125 pounds. Sam's weight is 4 times as much as his brother. Write an expression to show the total weight. Write an expression.
Write an
total weight.
Total weight.
And how heavy? What's the weight of one of them? How much each of them weight?
You know, you're in and out because we're having a little problem. Could you just say it again for our benefit? Sam and his baby brother Mac is what?
Together weigh 125 pounds.
Okay. What other conditions do you have in the problem?
Okay, I have Sam's weight is 4 times as much as his brother. Sam weighs 4 times as much as his brother.
Okay. All right.
Okay. Write an expression to represent their total weight.
Write an expression for their total weight.
And how much does each one of them weigh?
Okay, very similar to the one we had before. But how are we going to instruct this person to how did they arrive at 4 times whatever, 4 times the brother, smaller brother, younger brother? You know that you can be younger but not smaller. You'd have to be smaller. So Sam and his younger brother weighs 125 pounds. First of all, we have to give an expression, which I like. It's a 2-part problem, and you're building a structure. So we have
some 4P, and then your brother P.
Yes, but which one should they look for first?
In terms of
expressing the weights. Expressing the weights.
We know that Sam weighs 3 times as much as his brother. So I think the thinking is that you have to realize if you have an expression, well, you don't know his brother's weight. You use something you know he's weighing 3 times as much as his brother. So his weight would be 3 times whatever his brother's weight is. So the variable would be his brother's weight.
Did you say 3 or 4?
Sorry, 4. I said 4 initially.
Okay. All right. Now, I see some nice things about this problem. Tell me something nice you see about this problem. Anybody besides Miss Promise?
Nice.
I see something very nice about this problem. Anybody? Anybody? For a beginner, this is a perfect problem. Suppose, all right, you don't see it? Anybody sees how beautiful this problem is for a beginner?
Yes, because she steps it nicely. First you write the expression and then you solve. Very well done.
Nice. I like those features, but I see another feature here that I like very much.
The fact that she has the way she said it first, she gave you the sum of their weights, and then she went on to tell you that this one is 4 times as much. So I don't know, I get the feeling that, okay, well, I can now identify what one weight is, the unit weight. because you can now see that Sam, the first weight will be X, and the other one has to be.
What's wrong here today? Do you know what? When solve the problem with 4x plus x is equal to 125, solve that problem. And solve 3x plus x is equal to 125. Solve both problems.
Oh, I intentionally used 125 because I wanted them to get a whole number answer.
So what is x in this case?
25.
X is 25. Solve it with 3x when you were saying 3x. 3x plus x would give me
27.
Right? So it would be What is nice about this problem, since it's a beginner's problem, you're trying, what is the whole point here? Are you trying to find out decimals or fractions or what? Or are you trying to construct an equation using variables? Do you see any difference in what I'm saying here?
Yes, I do. It actually drives your point. You are getting the object.
Right. The thing is, I'm not testing decimals right this minute. I'm not testing or fractions or whatever. So the fact that you said 4 and 1, 5 is a nice number into 125, because what I'm trying to nail is how you build expressions and convert them to equations. Do we see that? Some teachers want to give them something that they get 4 and 19 over 86 or something like that, which doesn't make sense. Do we understand? So we don't do that because we have to decide on the objective. And this is algebra, which has some element the way we have built it over the years. We want to take away all that Twilight Zone stuff out of the mathematics in problem solving, right? So that is what I liked. What else? I told you what I liked about the other thing as well. Are we finished? We are? What was your question? You have 2 questions.
Yeah, we finished with one part because it was the expression, and then how much is each one weight. X is only the brother's weight. Sam's weight we have not found Sam's weight.
So what? So did we find your answer?
Yes.
What did we find?
100. Sam is 100 and the brother is 25 pounds.
So we have to teach our students to look at the question. How much did each of the boys weigh? Some children forget that and get half credit. When they have done the bulk of the work, they have done all the hard work, the heavy lifting, and they forget to look at the question again. So we teach that. We don't just let it go and assume that you're going to remember. So what I do is ask them to, in the problem, circulate. So how much did each weigh? What am I going to circle in that sentence? Each. So I have to be accountable. I have to give Sam's weight and I have to give Matt's weight. So you can even write that. The minute you get the idea, you write it down. Matt equals, at some space in between, Matt equals and Sam equals. Because if you can get 25 by doing the heavy lifting, you should not get half point because you didn't answer half of the question. Because you have the material right in front of you. So we have a small subtraction problem to get to, and something probably could do in their heads. 25 from 125 leaves 100. Anybody see the point that I'm trying to make? If you break it down like this, go ahead.
I see the point you're trying to.
Yes. So we do not leave our children with a whole lot of assumptions and leave them hanging. We nail it so that we can bring it to the front of the memory that they're.
No, I see.
Go ahead. Now it has disconnected. Yes. Okay.
I'm not hearing you. I think I have a problem.
Yes, we are having a problem. But anyway, remind our students to be accountable. Remind our students to be accountable. All right, I think we should stop there for sharing. And I noticed that some people weren't eager to share, but next time I'll get you. I'm going to write down the names of people who shared this time, and the next time I'm going to call you out. All right, now, so in those questions, those type questions, we have to teach them to be accountable. How are you going to account for the name of math, the age of math or the weight of math? How are you going to account for the weight of Sam? So the thing is, you have to teach accountability, and you have to double check, have I answered all the questions? All right, now, are we getting any kind of picture or structure in our mind as to how we introduce some of these basic algebra stuff in the 7th grade? These guys are having their first exposure to real algebra. The concepts have been skirted and introduced and so on, but now we're nailing it, right? So you have to be sure that you're building this structure in your mind, so that you will have an attitude of, I'm going to make my children successful. I'm going to make my children understand. Math is not in the twilight zone. There's something that I have to press here that, that stop this echo. All right. Now, write these things down. You can analyze them later, but the first one, and it's very similar to ones that you have done. So you guys have good information. You're on the same page with the author. And call somebody in there for me, please. The number of animals, they're looking at sentences. The number of animals is equal to 10 times the number of zookeepers. I'm having an echo when I speak. Okay, thank you. All right. You can go through what it is that you have to go through with the students if you give that kind of thing and help them to build, right? Same thing with Sam and Matt. What we're going to find the expression for two people, right? The two groups. It's not people. Some are animals and some are people, right? So what's the first variable I have to decide on? What is going to represent what? The number of animals is equal to 10 times the number of zookeepers. So we have to do zookeepers first and write 10 times Z. Okay, all right. There are 7 times as many toys as children. Can they write an equation for that? There are 7 times as many toys as children. There are 7 times as many toys as children. We could ask them to write that another way in their own words. And sometimes that helps them to translate into symbols. How can I write an equation for that? Not an expression, an equation. Because we are not told about sum of anything or anything like that. What is the equation associated with there are 7 times as many toys as children?
We write 70, we use T for toys and C for children, the number of children. We write 70 equals C.
Yes, that's an equation. Did we hear that? 7T equals C. But that equation has a feature about it that prohibits us from solving the problem. But nonetheless, we can write an equation. Do we see that? Do we see that?
Yes.
We do.
Okay. All right. Now we're going to generalize. I don't know if I can write it so you can see it. Right over here, right here.
No, come over someone.
Yeah, that should be fine.
Yes, we can see
Right
that.
here.
Yeah, I can see your hand, right.
Okay.
Right, big.
Bigger?
No, don't see it.
Right bigger?
We can see it.
Okay. I'm trying to write it. I hope everybody can see it. How can you express, I'm going to say equal to, as I'm going to say a sum or difference of 2 terms. We're generalizing now.
The difference of the squares.
A difference of squares.
Difference of squares. Do you see that? Yeah. So, you see, this is 4 times 4, right? And this is what? And the middle term drops out. Do we see that? So now, suppose I write this on the board. My children are able to see that. Do you see it? So now, if I write x plus y times x minus y, all they have to do is paste in. Do you see the pasting in? Do you see the pasting in, class?
Yes, we do.
All they have to do is paste in. They know these guys. Once you show it to them, they have no trouble, right? Because they can use the distributive property and they come to the difference of squares, right? Now suppose a child gives you, when they work it out, let us work out number 1. Let us work that one out, right? We're going to have, you know this pattern? Same way they used to do in primary school, right? You take this number, if you have 2 numbers, you take it and multiply, each one in turn multiply the top. Isn't that true? Yeah. Isn't that what we do? Right. So you line up something and you say negative times a positive, that means you have to know the rules, right? So we have, and we have negative 3 times 4 gives me negative 12. Step off 1, just like they were accustomed to in primary school. Do you see that? Step off 1. So 0 is a placeholder. Remember when we used to tell them that? All right. So we have plus and plus. So we have plus 12, because there's no mystery about it now. And 4 times 4 is 16. And then what we do? Add. Is that any different from in primary school? All right then. All right. So we're adding. So now 0 plus negative 9 is?
9. Negative 9.
Those 2 go out. Yes. And we have 16 minus 9. Now if my child gives that to me, that's okay. But I'm going to have to teach them something, because this is really 4 times 4. Do you see that? All right, now, when I'm going to teach the x and the y, I'm not going to write it like this, but I'm going to convert this to what I would write if I was using variables. Do you see what I'm saying? So this would be what? 3 times 3. Yes? And this would be negative 4 times 3, positive 4 times 3, because I'm pasting in the variables afterwards. I'm pasting it in. So we would have that situation. If somebody gives me this, I am happy. If somebody gives me, at their stage where they have, been introduced to indices, because all of my children should know the squares from 1 to 100 or 1 to 200, as the case may be. By the time they reach maybe what? When is indices introduced? Somebody help me.
Depends, This depends on how far.
No, standard, because I know there are lots of variabilities.
Grade 8, I think.
Right? So my guy is going to give me this in the 7th grade, and I'm going to be as happy as a lark, right? When we begin to look at indices now, I give them the same thing again. I said, can we express it equivalently? Right? And they should be able, if I lead them down this path, they should be able to do it. Algebra has not got to be mysterious. That's the whole point. Okay? Now we're generalizing because we have put all things of that structure under one umbrella. Yes? All right. This is a common one. I want you to have one of these guys set up. And I can draw very well. Woo-hoo. Can you see that? Can you see that? Can you see that, class?
Not very clever.
It's 5 squares
It's the red one.
Five tiles.
So it's the red one.
Red one is horrible on there. Let me use another black one. Let me write it over here. If I had a ruler, that would be better. Because I can't draw to save my life. If I had to earn a living by drawing, it wouldn't happen. I would be on the street approaching car window. Are you seeing it any better, Jeffrey?
Much better.
Goody good. All right. We can ask people to generalize by making structures, but we have to give them a starting point. And that is talking about patterns. Patterns, right? So what I want you to do, since I cannot draw, is to add a tile to each end point. So you're going to do this, and I'm trying to do it in red so you can see what I'm doing. Do you see that?
Yes, we do.
We are trying to get them to generalize. Yes? And we love to talk about N when we are talking about sequences, right? Yes? So then, this guy, he can approach it a number of ways, yes? He can look at what is happening. So everybody now write something about, make another one, because sometimes as you make it, you begin to figure out what is going on. So add on another tile at each tip. I would do it in different colors. Do you see that? I would do it in different colors to show that the black one is the first in the sequence. Black plus red is the second one in the sequence. Black plus red plus green is the other one in the sequence. And see if you can get to a general pattern. I'm hot. Why am I spending so much time on algebra?
Gatekeeper.
Gatekeeper. Because if I get my guys to begin to feel like, this is doable, this is not out of reach. Yeah, I'm going to be smiling all the way up to the 11th grade. All right, anybody comes up with an expression for the general term? How would you describe this picture? Just in your own words, at first glance, how would you describe this picture?
A cross?
A cross? It is a cross, but generally, if we're thinking about a cross in the religious sense, all the arms are not the same length. Isn't that true? We can have a longer piece for this.
Yeah.
Yeah.
It actually looks like an addition sign.
Ah, I like that. I like that. I like that. I like that. But if I'm way out there thinking something else. Anybody else? Somebody tell me something else they think of that could have that formation.
Junction.
Junction, yes, yes. What's a junction? Anybody knows in Dominica and St. Lucia? What do you
Where the roads intersect?
Yes, where the roads intersect. I didn't know that. When I went to take my driver's license, I say intersection. The man shook his head and said, junction. A junction. It's in the book. It's in the driver's license test booklet. But I said intersection, and he shook his head and said junction. I think it's the same idea. But you know what I'm thinking of? A nursing station in a hospital. The nursing station is the center, so they can have view of all that is going on in the different wards. Like, you know, suppose this is surgery, this is back or pains or fractures or whatever. They can see from all directions. But you know, you have Ward C, surgical ward, and Ward B is this. They can have one nursing station that at a glance, you can take stock of what is happening. And some hospitals are built on this pattern, where the nursing station, the hub of activity, and where the files are, and la, 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 but you can see, you can take a glance at all of the sections. So it's like a corridor, not a room thing, like a corridor of patients like that they have at KPH. Okay? But anybody come up? Anybody with a general pattern as to how this is formed? If we are looking at them as tiles. What do we notice about? What do we notice about the arms? You see my nursing station? Everybody knows what's my nursing station? My nursing station is here.
You just want to know when to start with.
Every one of them is my nursing station. My nursing station stays here, so the nurses can look down each of the corridor. I didn't say that so you could understand it. If I'm here, I can look in all, you know, not in all at once, but I can survey them easily. Okay, now, what do you notice about what I'm going to call the arms of the plus side in each of the patterns that you have drawn? They are the what? Anybody?
Doesn't seem like.
Goody. Very good. So they are the same length. But for any given picture, they are the same length. Are they the same length in all the pictures? Are they the same length in all the pictures?
No.
They increase with each picture. That is a good observation, but you can be more specific. No, you can be more specific.
In each direction.
They increase by
One
for each successive picture. So if you say, right, so how many arms it has? 4, right? So what is the expression for this picture right here to form a general sentence that describes all pictures of this? Because we're putting it under an umbrella. Do we see that? Yes? What is a general picture? The nursing station is forever there. And the nursing station is? Class, what's the nursing station in my interpretation?
It's a constant.
Aha, but you can be more specific.
X.
X is not a constant, darling.
You label it X on the.
Oh, that's the name of it. All right, I'm going to put NS. nursing station, right? So how many nursing stations we have in each of these figures?
One.
And one is the C word, constant. So you can put +1. We build it. So what you going to put on the other part of the plus sign? Is that a constant?
The number you add each time. Well, in this is
The number of the length of the arms are not constant, so you cannot put that. What is constant in the other part of the expression?
Stand by itself.
How many arms does it have?
Number of arms you add.
No.
Four.
I don't add any arms. I add, yes. So what can I say, class? So far I have my nursing station, which is +1, right? And how many arms do I have? How many things are in here? We have a nursing station as a tile, right? We have 4 arms made of tiles, and each successive picture, the length of the arms change. So what is the variable?
the length of the arms.
So we're going to call it what?
L.
L? All right. Okay. So we're going to call it L. Can we complete this expression, class? Can we complete this expression right here? What we're going to put here? There's a big place to put something. Look. Put something in here. What we're going to put? What we're sure we can put? We're sure that we can put 4L. Do we see that, class? Do we see that? Hello?
Yes, we do. Yes, we do.
All right. So we know we have 4 arms in all the pictures. So that's constant. But the length of the arms is labeled with a variable. So if I ask you, what is the 5th picture in here? Right? You're gonna get it. The first picture is what? The first picture is
4L. That's 1.
and L is in the black.
1 length.
So the first picture has how many tiles?
5.
5 tiles. Do we see that? Hello?
Yes, we do.
Okay. So then, my guy, now, we're going to check out since we have 3 pictures in front of us, we can use this expression and test. Do we see that? So for the second picture, this part is good, right? This part is good, but this part changes from a 1 to a
2.
So we have picture number 1 is 5. Picture number 2 is 9. What is 9?
9.
9 plus 4.
Picture number 3.
9 plus 4.
13.
13. Do you think if I am teaching them sequences, right? Am I beginning to hit something here?
Yes.
What am I beginning?
Pattern.
Pattern. So, what is this telling me?
That it increases by 4 every time.
If I ask somebody to give me a pattern, tell me how many tiles are in the 5th or the 10th or the other, I could go the long way and I'm bound to get full points. I mean, the teacher has no choice because I didn't leave that teacher any choice because I did it muscle intensive, labor intensive. Do we see that? So here we have 4, and this guy is supposed to be plus 4, so it's going to be
17.
Right? Hello?
Correct.
All right.
You're correct.
So we have 5 now. and that wouldn't be any sweat. But why it is that we do not ask them to give us the 5th one, because they can muscle it out. But to generalize, we might say the 10th. Some people might use reams of paper, right? But we know what we notice between, let me write this out. What we notice, this is what plus 1? This is 4 plus 1. What is this? 8 plus 1. This is 12 plus 1. Plus 1. So you see what is happening to this number right here? This number is increasing by 4 each time. Right? So here we have a situation where we have a pattern to go by. This is what? 1 times 4, 2 times 4, 3 times 4, right? So if we want the 10th one, we could go down without muscling it out like this. Do we see that? Okay. So it can be labor intensive at first, and once you begin to get the pattern, you begin to speed up. All right? Okay. So here we have a situation where we can generalize. Okay, so may I ask a question? I'm going to stop at 6:30, so we have 10 more minutes. Did anybody manage to get incomplete version of what the second assignment is? It's on your, it's supposed to be on your computer now. But I want to tell you 2 things, so listen carefully. Listen carefully. And I don't even know what to tell you to listen carefully too, because I don't have my, 1 week from the 12th is the 19th. So you're getting 2 weeks to do each of the assignments. From this to the 19th, from today to the 19th is 2 weeks. So that 30% one about the ICT, and I've spelled out all there are 4 points to that.
Dr. Nelson, did you email it to us as well? Because we haven't got it.
I did email it, but it was pretty close to the beginning of class, so I don't blame you if you haven't seen it.
Okay, we haven't gotten it.
It's there though. But, yeah?
Sometimes things go into spam, but it shouldn't.
It hasn't been going into spam when I send it to the whole class. But listen, just to give you an idea, we said use the websites given to determine the use, value, and necessity to use. You don't have to write it down, just listen so you can get an idea. Use, value, and necessity to use ICT in the classroom. Discuss, number 1. Number 2, discuss how ICT may benefit the teaching at your school. Of mathematics, I should say. But the personal tablet didn't put that, but you know. Number 3, discuss how to plan for effective use of ICT in the teaching of mathematics. Number 4, I want you to go to do some research. Give updated examples, like now, current, right? For more recent research findings with ICT, right? Use of ICT. It's due on the 19th, which is not in the email, so write that down. It's due on the 19th, and it's 2,500 words. A follow-up.
Dr. Nelson, I just checked my email and we have not received it, huh?
Oh boy. Well, Miss Mills will send it to you because I left a hard copy over her office, and she will send it to you on Monday, Friday.
Okay.
But you have an idea of what we're talking about, I hope. Hello?
No, because no, but we still need the instructions. You were reading it so fast, I wasn't able to write it down.
No, I don't want you to write it down. I want you to get the idea and the mindset. Because I tried to send it to you today over at the office. A lady sent it for me, but I guess she didn't know what it was. But anyway, discuss using websites given to determine the use, value, and necessity to use ICT. Just listen, don't write, it's coming. Discuss the benefits. How ICT may benefit in teaching at your school. 3,
You don't have a school?
you have to go with a vicarious experience. So you have to do the research and say what they find and that kind of thing. Okay? Discuss how to plan the effective use of ICT in the teaching of mathematics. Number 4, give updated example from more recent research findings, like, in the 2000s. Get something on that and see the feasibility. What we are doing here is getting educated. It might not be happening for all the constraints that Jefferanne pointed out. Maybe lack of working equipment, maybe no plans, maybe no desire, maybe the know-how is not there on the part of the teacher, so it would not, the lesson would not flow smoothly and so on. So you have those kinds of constraints that we discussed. If you did not get all what we were saying, you can go back and listen to the lecture from Monday and you'll pick up some of those things because they're in there. I don't mean that it has to be used at your school, but at least your awareness should be heightened by this exposure.
And what do you say is waiting for this one? 40%, right?
30. It's 40, 30, 30.
Dr. Nelson, we still have a third one, right?
Yes, that's what I said, 40, 30, 30. I'm going to give you the next one by the weekend. Because you're going to, what is 1 week from the 19th is the 26th. The next one will be, the third one will be due on the 26th. I'm giving 2 weeks for everything. Well, the one that I get on the 12th, I'll mark it in real time.
Okay.
Trying to mark them, yes.
The last one.
The last one, I'm going to be a Maverick. What do you call it? Maverick. 4 weeks are so short, it's a short time. Next time we are going to lay off, we're going to go to assessment of mathematics learning, or probably we did some of that last semester, so probably what I will do is, I'm going to do number sense number sense is very important. We touched on it last semester, how children learn mathematics, but I want to nail it again now that we are looking at algebra, because the number sense in algebra is going to be critical. Because what happened, we have to now interpret what is reasonable in terms of the numbers in the problem. You see what I'm saying? Because we don't know the answer to the variable. But if, like, when we get -6 or -7 for the person's age, we need to say number sense tells us, we do not have the full story represented in the equation. Do we understand that? So what we want to do is heighten those things because they're so applicable across the board. And if you give people general tools, right, they can apply them to a variety of situations. Number sense can be applied anywhere, right? If I have x plus a quarter is equal to, I don't know, 5/8, right? We are going to have to see that we cannot add or subtract fractions without same denominator. So I'm making this up as I go. So we have to make same denominator. So a quarter is 2/8, right? 2/8 and 5/8 don't make 1. So if you're getting something really weird, you know it's not happening. Do we understand? That's the number sense I want my students to have. Because when I'm traveling someplace and I see a sign, and I have a big idea of where they are, plus my present location, I should know that I might not know where I'm going, but I know I don't want to take this turn off, or I don't want to take the other turn off. You see what I'm saying? Yeah. So that's what I want to do. And I want to make sure that you arm your students with the ability to fall in love with mathematics. They should never ever think that this is beyond them, because it isn't. Business people do math very quickly, and they say they weren't good in math. But you know, I'll tell you about my trying to buy a range hood for the kitchen. Very soon, ATL will be the only person who carries it. Every hardware store I call, we don't have carrot, miss. You could try ATL. We don't have carrot, miss. You could try ATL. Why it is that ATL carries it, and everybody knows it, and not the other? What is one reason you could guess? What is one reason you could guess? To carry these things, the other day we spoke about it, right? They're doing mathematics. This super value that they have up here, they have 6 left. She said, Miss Len, these are sold, we're not carrying it anymore. Why is ATL able to carry it, and some of these other guys are not carrying it? Have you ever thought about that? It's a business decision. It's a mathematics problem. Why? Why?
Usually based on the supply demand sales, they decided not to continue because it's not doing well.
It's not doing well. It's not something that is in high demand. Maybe PCD pads, everybody carries. The one on the corner, the one in the mall, everywhere, because of the demand. Now, why is it? Think about why is it that ATL is able to carry it? Well, the customers come from everywhere.
Different customer base.
Different customer base is one thing. There are some other reasons. Can you think of any other reasons, class? Why this big ATL is one of the biggest, right? Why do they carry it? And everybody knows it. But big warehouse, you can something that is, you have to have a different reason besides big warehouse. But space cost overhead.
Yeah, but their cost overhead may be less.
Why? They're in the same, they're on Constant, which road they're on? They're on Halfway Tree Road, Constant Spring. That is Halfway Tree Road, right? That's big real estate prices down there.
Well, where's the warehouse?
Yes, but they have to put it in the store. Some people, there are lots of things happening with marketing here. Do you know that some places that people have branches, you know, like in America, I can think of one, Starbucks, a coffee place. They're like gas stations. Almost every corner there's a Starbucks, right?
Yes.
Some of them function at a loss. Some of the outlets, but they want to become a household name. They want Starbucks to roll off your lips every time you think coffee. But the profit they make at other stores compensate for that. But they are known, they have customer loyalty because it's so easily accessible and those kinds of things. Now, ATL is more expensive than some of the hardware stores. But if they come to be known in the customer's mind, that is a one-stop job. If you go there to buy 2 things, and a third thing that you want is there, probably you just decide to buy it because it's not entail it, to acquire the third thing does not entail driving further and la 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 la. So sometimes it's a one-stop, the convenience, the customer friendliness of the one-stop thing, and so on. So it's not always money that makes a decision. But some of these smaller stores say, if I carry more PCV, I can tell people more often, yes, I have it. Because in the year, 5 people come into my store about range hoods. And 65,000 come in here for, because it's not 65,000 individual, but you know, the plumber or the whatever coming here for PCV. He was well known to the guy. He knows where to go pick up his stuff. He doesn't ask any question, etc., etc. So you see what I'm saying? A lot of decisions go into business, and it's the mathematics of it. Because when you get customer loyalty, as you wake up, you think ATL, because I know when I go there, I don't have to search around, and then don't have to go to this store, that store, that store. So they might forego the reduced profits they make off range hoods, but keep it just to say, if you're buying 2 other things or 3 other things, I can say, yes, I have a range hood. You see what I'm saying? And same thing, the idea with Starbucks. They run places at a loss. But everybody, when they wake up, because it's a status symbol. And you like KFC is a status symbol in Jamaica. You make sure everybody see you have a bag. You will never see me reborn. It is.
It's in St. Lucia.
In St. Lucia, what is the status symbol?
Or maybe somewhere like rituals or something like that.
Okay. I'm not familiar with that. I came to St. Lucia for a little while. And I have a confession to make. I went to St. Lucia on the Eastern Caribbean cruise, yes. All right, is there any other question, comment that anybody would like to make? I have a question. Are we getting anything that we can take away to take to our classes from this exposure?
Yes, we are.
Okay.
Yes, we are.
I hope you remember them, because I want my students for you to start a trend in your school where your kids just are flying off the A charts. Okay, have a good afternoon. And all the Jamaicans, please have a good Independence tomorrow. Tomorrow is our Independence Day celebration.
Good evening and have a happy Independence.
Happy Independence.
Thank you. We are how old? 50, from 62 till now, 53. So tomorrow we're going to spree because it's 53. Bye-bye.